That is, you can get it directly through them, or you can get an all-access code through UF. Either one of those is fine. If you've done one, that's fine. If you've done the other, that's fine. I don't recommend buying it twice, personally. But if you don't like money, then there's probably other ways you can get rid of it. As far as Zybooks go, there are 3 ways you can get access to Zybooks. Despite the fact that apparently the bookstore staff don't realize it, they do have Zybooks codes there, and you can buy them. And I have now emailed them several times asking why their cashiers keep telling students that they don't have it, because they do. They do, and it's been verified by a couple of students at this point that they did in fact buy it there, and others that they had it. However, the bookstore is more expensive, I guess because they can get away with it. So if you buy it through the bookstore, it's $90. If you buy it directly through Zybooks, it's only $60. I don't make that decision, so please don't shoot the messenger. You can also, if you need to wait until your financial aid comes in, I emailed out on an announcement a way for you to get access to Zybooks temporarily while you wait for your financial aid to come in, so that you can get it directly through them, but pay once your aid comes in. So there are 3 ways. Any one of those is fine. If you've done one, you're good. You're set. Both of the platforms are used in labs. Some of you have already started. How many of you have been to lab already today? Okay, wow, a lot. That's more than I thought. So a lot of people have already been to lab. I know that there were a couple of minor bumps, but largely it went smoothly. So you've already seen that we're using it in lab. Everybody else is going to be using it in lab as well. So please keep that in mind. You are going to need it for lab. I think that is everything. So I'm going to go ahead and pull up my slides, which I haven't had time to push on Canvas yet, but I will be pushing them up pretty soon here. Okay. I'm going to get this microphone working eventually. Okay, so let's talk about programming. I'm going to slide through these slides we've already done. So let's talk about how we actually pull together a program. So you probably already played around with some of this a little bit. Yes, sir. Okay. Roll call attendance. What says that? On what? Yeah, I'm sure it's just a mistake. I'll fix it later, okay? So I'm not actually taking attendance here or in labs, but you got to be here to get credit for the quizzes in the labs. So, so let's talk a little bit about how these programs come together. Hopefully you've played around with some of these. You've seen some examples up to this point by going through the first chapter of Zybooks. Just to clear it up, because a couple people have asked me, the activities in Zybooks, other than the labs that we're doing in labs, are not required. However, I do recommend doing them because they're a pretty good way to learn the basics of programming, right? That's kind of a function of it. And you are responsible for understanding how those things work. When it comes down to individual statements, we talked a little bit last time about how a program is made up of statements. The individual statements in Java can be pretty complex. They have a lot of different moving parts. And even something as simple as just printing something to the screen, it's system.out.println, and then an open parenthesis, and then whatever we want to type on the screen, and then a closed parenthesis, and a semicolon, right? So pretty complicated. All statements in Java end with a semicolon, right? That's how we terminate a statement in Java. We say, I'm done with this statement, this instruction. This, when we make a call like this, when we give the computer some kind of instruction that comes from an object, which we're going to talk about a little bit later, that's called a method. A method is a way that you tell some data type to do something. In this case, what we're doing is we're telling the system's output to print something to the screen. So we're saying, hey system, go to your output object, the thing that lets you do output, and print this to the screen. And give it a new line after you're done. That's what print line is. So there's also a print command, which is a little bit different from print line, and that print does not add a new line, and print line does add a new line. So this will add a character return, so it'll start back at the bottom. Okay, So that's the basic layout of a statement. This particular statement has one argument. An argument is a piece of data that we're trying to send into a method, something we're trying to deliver as a piece of information to act on. In this case, that one piece of data is this, what we call a string, which is just a sequence of characters that says first Java application. So that's called a string. In fact, this is a certain type of string called a string literal, because we literally type out what it is, right? That's why it's called. And I know literally doesn't mean the same thing anymore, according to some people, but in this case it does, right? When we talk about a string literal, we mean we're actually giving it the exact data that's going to go there. Anybody have any questions up to this point? So, yes, sir.
When you say a method, is there a difference between a method and a prototype?
That's a good question. The question was, is there a difference between a method and a prototype? And a prototype is not something actually that we use in Java. Are you getting this from another language?
I'm thinking JavaScript.
You're thinking JavaScript, yes. So it is different. A prototype usually is, we just say what type of something it is. A method is actually the whole shebang. It's the whole thing. So I can get into more detail about the difference later if you want to ask me, but I don't want to get off track and talk about JavaScript. But yes, they are a little different. But does that answer your question for now?
Yeah.
Yeah.
Sorry, I just didn't realize there's like, didn't exist in
Yeah,
Java.
yeah. So yeah, prototypes don't exist in Java because it's a very different style of language. And I'd be happy to talk to you about more details later, okay? All right, anyone else? All right, so far so good. So I know some of this is a review because you've seen it in the book, but we're going to go over it so that everybody has a couple of examples. So let's talk about this method called main. Main is a method, and when we have a main method inside of an object, it means if we use that object as a program and run it, then the main method is where the program starts. Main methods or functions exist in a lot of languages. Usually they're called main, but it's the entry point to the program. So in this case, we have a class called Howdy, and we're going to get into more detail about what that means later when we talk about classes. But for now, you can think of it as like a blueprint for something. And inside of that, we have this thing called main. And Java is a language that has a lot of what we call boilerplate, which means there's a lot of things you have to do just to get something to appear on the screen. In this case, we have to define what this main method is. We have to say, we're saying, okay, this is a set of instructions that I'm going to give to someone, and here's how you execute those instructions. In this case, our main method is void, and that means it doesn't return anything. It doesn't give you anything back. It just does its thing, and then it's done. It doesn't mean that main is empty. It still has stuff in it, right? And it doesn't mean that it doesn't produce output. In this case, it does produce output. It's going to print hello world to the screen. So all void means is that once it's done, it doesn't return any information to the user. It's also what we call a public method, which means it's generally accessible to everyone. And it's a static it's a static method, which means that we can execute it without having a data object. It can execute all by itself without any kind of special springing point. And we're going to get into more details about what these words mean, but I know it can be confusing when you first see the signature, so I wanted to cover the basics. So we're going to get into more detail further down in the class as to what are objects and what are classes, exactly what these different terms mean. But if you're wondering where these pieces of the puzzle come from, that's where they come from. Generally speaking, when you write a Java program, and especially the first several examples we're going to go through, they're always going to start with some class, which is like the program name, and we can call it whatever we want. And they're always going to have a public static void main function that is the starting point. So this is the boilerplate that I'm speaking of. And then, inside of that, we'll have the individual instructions. Is anybody confused by any of this? Yes, sir.
Can you change main to Howdy and it'll still work?
That's a good question. Somebody said, can we change the name of main and still have it work? And the answer in Java is no. And the reason that that's the case is because Java specifically looks for something called main to get the program started. So you could change it to another name, but then Java wouldn't be able to use it as a program to run. It could use it later to do something else, but you couldn't use it as the main entry point for the program.
Oh.
Does that answer your question?
Mm-hmm.
Yes, sir.
What if we got rid of the static tag, so just the public void?
If you got rid of the static tag, then you would have to have an object first, which is going down a really deep rabbit hole that we're going to get into later. But basically, the short answer is it won't work because it needs a data point to spread from. I forget whose question that was. Was that your question? Okay. Does that answer your question for now? Okay. It won't work if you take away static. Does that answer it now? Okay. Yeah, we're going to get into more about classes and stuff. But for now, I think it's best just, you're going to need to have that there or the program's not going to run for the moment. Anyone else? Yes. Oh, yeah, that's a good question. Somebody said this in here inside these parentheses, there's an argument. It says string args. And the answer is that how many of you guys have ever worked from like a command line program like DOS or Linux or something else? Like opened up a command line? Okay, not that many. Okay, so when you run a command line program, it can take in a number of arguments from the command line, right? Like you can type, if this program is called howdy, right? I could do Java howdy to run it, and then if I wanted to add other information, I could do Java howdy and some message. And that message would get passed in as this args string. Does that answer your question? Yeah. Okay. Anyone else? Yes, sir.
If you had no need for input from the user like that, could you leave those parentheses empty?
I know you can do it in C and C++. I actually don't know if you can do it in Java. I think it might crash. But it would be easy to check. You could just try to compile it. It may not run. Oh, I'm sorry. Yes, I'm supposed to repeat the question because nobody can hear. The question was, if I don't need input, can I just leave this out, like this parameter? Can I just do main open parenthesis, close parenthesis? And my answer was, in C and C++, I know you can do it, but actually I don't know if you can do it in Java. I would have to test it. No, it doesn't work? Okay. That's what I suspected. I suspected it wouldn't work because Java's pretty picky about stuff like that. So the answer is, no, you have to have it for Java. Yes, sir?
You put void, but then it's returning hello world, so I'm kind of confused.
Okay, so that's a good question. He said we called it void, but then it's returning hello world. But actually, it's not returning hello world. It's printing it to the screen. There's an important difference between a function that spits information back to the program that started it or the function that started it, and something that prints something to the screen. It's a subtle but important distinction. Printing something to the screen is not the same as returning a value. Returning a value means we execute something, and we may not print it to the screen at all, but we pass it back to whoever started the program or started the function or something like that. Does that make sense? Sort of? So let's say we had another program that started our howdy program, right? We had another program called initialize greeting or something like that. If howdy gave information back to initialize greeting, then that would be a return value.
Okay, got it.
Does that make sense?
Okay.
Yes, in the back. Could I give some examples to the alternatives for public and static? I definitely can. We haven't talked about objects yet, so the alternatives I can tell you is that if you leave static off, that this won't work in this case because we have to have an object, which is another. One of the problems with Java is that it has a lot of bits and pieces that have to work together, right? So you can leave off static if you had an object that you were calling this from, and you would have to work some magic to get it to run properly. But it would be complex. For public, we can also have what we call private methods. And private methods can only be called from their siblings. So, sorry, on the fly, I'm trying to think of an example. Basically, we can definitely leave those off, but the examples are complex, and we are going to get to them later. So does that answer your question enough for now? Yes, okay. All right, anyone else? So we've talked about the basic statements, right? What about comments? You guys probably read about comments. Comments in C, C++, and Java, there's a couple of different kinds. A comment is a line that is not going to be compiled. It's not going to be turned into machine code by the compiler. So in this example, we have a couple of different types of comments. The first one is a block comment, and it says, this program prints hello world on the screen. So anything between those two sets of symbols, the compiler is not going to turn into machine code. The only purpose of comments is for human readability. We put comments in so that we can understand when other people wrote code, why they wrote it, so that we can communicate to the people who use code after us what the reasoning was that we wrote this line of code. Or it's so that we can leave notes for ourselves so that we can go back and look at them later, so when we read the code, we understand it. So, you know, something like, anybody have any idea how many lines of code there are in Windows or the Linux kernel or something like that?
Millions.
Millions, like literally millions of lines of code, right? So even if you write a line of code yourself, like I write code, I've written a lot of code, and I'll go back to some code and sometimes I'll wonder, what the hell was I thinking, right? I have no idea what I did. And if I don't leave comments, I won't be able to figure it out again. And you're going to have this experience too. And most importantly, if you're in a job, comments are important because you're going to be writing code with other people. And when you write code with other people, sometimes someone's not going to be able to understand exactly what you meant to do just by the code that you wrote. So you're going to have to add these comments to make it a little bit easier. So it's a way of documenting the source code that you're writing as you write it so that you and other people can understand it later. So I mentioned before there's a couple of different types of comments. One of them is called a block comment. And this block up here is a good example of that. So we have a starting and an ending for a block comment, which is slash, asterisk to start, and then another asterisk and a slash to end the comment block. Anything in between those starting and ending points is not going to be turned into machine code. It's a comment, and it's only for human readability. We also have inline comments or line comments, and that is when we use a double slash, right? So the double slash means anything after those two slashes is commented out. When we say we comment out something, what we mean is that those lines do not get executed. Anything after that doesn't get executed. So this is also a good way for us to debug. We might take lines of code that we've written, if we don't want them to be a part of the program, but we don't want to delete them because we're not sure they're totally wrong, we might add a couple of slashes in front of the code so that it doesn't get turned into machine code. So we can do this at the end of a line. We can also do it at the beginning of a line. So this example right here is an example of commenting out a line of code. So we add the two slashes in the front. Now this line of code will not be turned into machine code by the compiler. Right up here, we have a comment at the end of a line. So everything before that will be executed, but this section here will not be because it's been commented out. Any questions up to this point? Okay, so the only other type of comment we have is what's called a JavaDoc comment. And a JavaDoc comment is a special type of comment that's used for automatically generating documents, like readable documents later on. We're not going to get into too much detail about them, but they're a specialized type of block comment that starts with two asterisks. Excuse me, starts with two asterisks instead of just one. So slash, asterisk, asterisk to start, and then just like before, an asterisk and a slash to end. And this makes it so that anything you put inside those blocks will all automatically be pulled out and put into like an HTML file when you run a document generation program on your source files. So you can read a lot more about this if you're interested. JavaDoc is the standard, and almost all Java APIs are written using this. Like anytime you have reference manuals for Java, almost everything that comes from those is generated using JavaDoc comments that are actually in the source code itself. So it's a way that you can actually write information